All right, welcome to another deep dive. Today we're going deep into Arabic and Islamic natural philosophy and science, and we're going to do it with a very specific goal in mind.
Yeah, imagine you had to explain all this to a philosopher who, well, let's be honest, but probably hasn't spent much time thinking about this stuff.
So we're talking core concepts,
Hmm.
arguments, like the nitty-gritty of how these thinkers reasoned about the world.
Exactly. And we're drawing primarily from the Stanford Encyclopedia of Philosophy, so you know it's going to be good.
Right. And to really understand the ideas we're diving into, we got to know the scene, right? The intellectual landscape.
So picture the medieval Arabic-speaking world. You've got two big players, Kalam and Falsafa.
Kalam being like Islamic speculative theology, right?
Yeah, and Falsafa, that's more like philosophy directly inspired by the Greeks, mainly Aristotle. But these weren't just different names. These were different approaches to understanding the universe.
Different starting points, different methods.
For the Kalam folks, theology was huge.
Yeah.
So they often start with a specific doctrine and then reason about nature in a way that fit with that doctrine.
Like atomism, right?
Yeah, atomism was a big one for them. The idea that reality is ultimately made up of these tiny, indivisible particles called atoms. And this had big implications for how they thought about causality, often leading to the idea of God as the sole cause.
Okay, so atomism.
Now, Falsafa, they were all about Aristotle. Continuity, natural capacities for change, and understanding causes within nature itself, like inherent properties and forces.
So we've got these two schools of thought with their own distinct starting points, trying to answer those big fundamental questions. What is matter? What is space? What is time? What is change? What is causality?
You got it.
And
It's like having two different philosophical systems trying to explain the same phenomena.
All right, let's start with Kalam atomism. What was their picture of reality, like their basic building blocks?
Okay, so Kalam atomism, they had three main ontological categories, right?
Mhm.
You've got your atoms, these indivisible bits of matter.
Like the smallest possible pieces of stuff.
Then you've got accidents. Those are non-spatial, so they don't take up space, but here in the atoms.
Like qualities or properties.
Exactly. Things like color, taste, smell, even things like force and volition.
Uh-huh.
And then, of course, you've got God, the big guy.
God being the ultimate ground of being.
Yes.
The creator.
Yeah, that's the foundation. And their argument for this often starts with the idea of the world's creation. They say, look, an actually infinite past doesn't make sense.
You can't traverse an infinite series.
Right, so the universe must have had a beginning, which means there had to be a creator. And this creator, what did he make?
Stuff that takes up space, atoms or qualities of that stuff.
Accidents.
So they linked their theology to their physics.
It's all connected.
Yeah.
And then they had these super interesting arguments for why matter has to be atomic. Arguments that basically aim to shut down any idea of infinite divisibility.
Like they didn't buy the idea that you could just keep dividing something forever and ever.
Right, because that would mean an actual infinity of parts, which to them was absurd.
So one infinity can't be bigger than another infinity.
Exactly. They even extended this to the idea of potential infinite division. Like, even if you could keep dividing something forever, who's actually doing the dividing?
God.
Right. But if God were to actualize an infinite number of divisions, you'd still end up with that problematic actual infinity.
So either way, you run into problems.
Yep. And then they brought in Zeno's paradox, the one with the ant and the sandal.
Oh yeah, if the sandal's continuous, the ant has to cross an infinite number of halfway points.
And since you can't actually complete an infinite number of tasks,
the sandal can't be continuous. It has to be made of a finite number of parts, like atoms.
bingo. And they also pointed at differences in size, like a tiny speck versus a huge mountain.
Right. If everything's continuous and infinitely divisible.
Then both the speck and the mountain have an infinite number of parts.
But the mountain is clearly bigger, so how can that be?
Yeah, it's like they were wrestling with these paradoxes of infinity and continuity, something that still trips up philosophers today.
Okay, so they had all these arguments for atomism, but what exactly were these atoms in their view? Were they like tiny little balls or something more fundamental?
So initially, some scholars thought that these early Kalam theologians were talking about point-like atoms.
Like atoms with no size, just locations.
Yeah, but more recent scholarship, especially Elnor Danani's work, has made a pretty convincing case that actually both early and later theologians were thinking of atoms more like Epicurean minimal parts.
Okay, so what's that?
Imagine these indivisible space-occupying units. They don't have internal parts and they don't have inherent dimensions themselves.
So they constitute extension.
Right, but they're not extended in the sense of being divisible. Think of them like the ultimate boundaries of space.
The smallest possible unit that can take up space.
Exactly.
Okay, so you've got these featureless, indivisible atoms, but the world we see is full of different qualities and properties. How did they explain that?
That's where accidents come in. Remember, atoms themselves are homogeneous, no inherent qualities.
Like they're all the same.
Yeah, so all the variety we see comes from these accidents that inhere in them.
So an atom doesn't have color itself, but it can have the accident of redness.
That's the idea. And they had a huge list of accident types, not just sensory stuff, but things like force, power, will, life. Even existence and ceasing to exist were accidents.
Wow. So for them, when something changes, it's not the atom itself that's changing, but the accidents inhering in it.
Right. The atom stays the same, but the accidents can be replaced by their contraries.
Fascinating. Okay, so they had this atomistic view of matter. Did they extend that to space and time as well?
That's where things get even more interesting. The idea of discrete space was definitely debated.
Meaning space itself is made up of these tiny atom-sized units.
Yeah, some argued for that, but others thought space was this continuous background that atoms exist in. One of the arguments for discrete space was this three-block pyramid thing. Imagine trying to arrange three atoms.
In a pyramid shape.
Yeah, but if space is continuous, you could theoretically shove those atoms together so tightly that you'd create a magnitude smaller than a single atom.
Which shouldn't be possible if atoms are the smallest things.
Right, but proponents of continuous space had their own counter-arguments. For example, they talk about the forces that move atoms around, how those forces would work in a discrete space.
It seems like a really tough question. Did they reach a consensus?
Well, later theologians seem to lean towards the idea that all magnitudes, including space, were ultimately discrete.
Okay, so maybe leaning towards atomizing everything. What about the void? If you've got these discrete atoms with space between them, does that mean there's empty space?
Ah, the void. Another hot topic. The idea of a void was really hard for many of them to swallow.
Like, it's hard to imagine nothingness as something that exists.
They'd argue, how can something that doesn't exist have properties, or even be a condition for the existence of something else?
Plus, there's that classic idea, nature abhors a void.
Yeah, they'd point to examples like the suction of a cup in glass. But those who did argue for the void would often use the same examples to support their view.
Like, maybe the cupping glass example just shows that matter resists the void, but doesn't prove it can exist.
Exactly. Or they'd come up with thought experiments involving specific arrangements of atoms that would require empty space.
It's amazing how the same evidence could be used to support opposite views.
It really is.
All right, let's talk about time. So Maimonides, he thought that the Kalam had a unified atomic theory of time. But our sources seem to suggest a more complex picture.
Yeah, Maimonides might have oversimplified things a bit. Al-Ashar himself actually presents three different views on time.
Three different views from the same guy.
Yep. One view is that time is just an aggregate of moments, maybe atonic moments. Another is that the moment is an accident that inheres in an atom and determines its temporal location.
Okay, so time is like a collection of these time-stamped atoms.
In a way. And the third view, which was probably the most popular, tied time to some observable event, usually the motion of the celestial spheres.
So if the motion of the heavens is discrete, then time itself is also discrete.
Right. So while there wasn't necessarily one single, fully developed atomic theory of time that everyone agreed on,
The ingredients were there.
definitely.
Okay, so we've got this potentially atomistic view of matter, space, and time. How did they explain change? And what about causality?
Good questions. So for the Kalam folks, change was mostly understood as the replacement of one accident by its contrary. Like I said, the atom itself doesn't change.
Just its properties.
Right. But when you're talking about more substantial changes, like one type of substance turning into another,
Wood burning into ash?
they often use the theory of latency, or Kuman.
Which basically says that the atoms of the new substance were already there, hidden within the old substance.
Yeah, kind of like potential waiting to be actualized.
Almost sounds like Aristotle.
It does have that flavor. But there was also a debate about whether change itself was a single thing, or if there were fundamentally different kinds of change.
Like, is motion a different kind of change than, say, a change in color?
Exactly. Some argue that there had to be different kinds of change because some changes lead to contradictory effects, like fire can only heat, it can't cool.
Right, well, motion can be in opposite directions.
But others argue that motion itself is just one kind of change, even though it can result in different states. They also debated where exactly motion happens.
Where motion happens, what do you mean?
Like, does an object move at the starting point, the destination, Or does it need to be in two different places at two different times? Abu Hudhayl, for example, liked that last idea.
Wow, that's getting really specific.
They went deep. And then there's causality. Now, this is where Kalam thought went through some interesting developments.
Okay, tell me about it.
Early on, many theologians believed in this idea of engenderment or tawalud.
Engender.
It basically means that created beings, especially humans, have some genuine causal power. But they said true agency requires knowledge of both the action and its intended result.
So only God and humans can truly cause things because only we have that kind of knowledge.
That was the argument. And then they debated just how much causal power humans had.
Like, can we only cause changes within ourselves, or can we also cause changes in the external world?
Exactly. They'd use examples like striking someone and causing them pain. But then later on, Kalam thought shifted towards occasionalism.
Occasionalism. Isn't that the idea that God is the only cause?
That's the one. They believe that God recreates the entire world with all its atoms and accidents at every single moment.
So there's no such thing as a secondary cause.
Nope. Everything is directly caused by God. And one of their main arguments was based on the idea of possibility, or istia.
Okay, how does possibility lead to occasionalism?
Well, they said that a creature can only act if it has the possibility to act. But if that possibility exists continuously without being actualized all the time,
Because we don't act every single moment.
right, then you'd have a non-actualized existence, which they saw as a contradiction.
A contradiction.
Yeah, because something that exists can't not be actual.
Yeah.
So they said the possibility to act must be created by God at the very moment of action.
So God gives us the possibility to act whenever we do act, making him the only true cause.
That's the logic.
Mm-hmm.
And as you can imagine, that has huge implications for how we understand things like natural laws and free will.
Yeah, that really shakes things up. So we've talked a lot about the Kalam atomists, but it's important to remember that not everyone in the Kalam tradition agreed with them.
Totally. Al-Nazam is a great example of a dissenting voice.
Oh, right, Al-Naz Azam. He was a bit of a rebel.
He rejected the whole atom accident ontology that most Kalam thinkers accepted.
He didn't believe in atoms or accidents.
Not really, except for the accident of motion. He thought bodies were continuous and that they existed in a continuous space.
Which, of course, creates problems with things like Zeno's paradoxes.
Yeah, the atomists were quick to point that out.
If everything is continuous, how do you explain motion without running into those infinite divisibility issues?
Al-Nazam had a pretty wild solution for that. He called it the leap, or tafra.
The leap.
Yeah. He said that a moving object in a continuous space can jump over infinite points without actually being present at any of them during the leap.
So it's like it teleports across space.
Kind of. He believed motion could be discontinuous, even in a continuous medium.
As a philosopher, I gotta say that raises a lot of questions.
It does. But Al-Nazam went even further. He said even the atomists had to admit the existence of leaps. He used the example of a rotating millstone.
Okay, a millstone. How does that prove leaps?
Well, imagine an atom on the outer edge of the millstone. It's moving a lot faster than an atom near the center. Right?
Because it has to cover more distance in the same amount of time.
Exactly. Now, the atomists explain differences in speed by saying that slower objects have more moments of rest between their movements.
Like they're moving in tiny jumps with pauses in between.
But Al-Nazam argued that if that were true, the millstone would fly apart, because the atoms at different radii would be moving at different rates with different numbers of rests.
Because the outer atoms are moving much faster, they'd have fewer pauses.
And that would create a lot of tension and eventually break the millstone. Since that doesn't usually happen, he said even the atomists had to secretly rely on something like leaps to keep the millstone intact.
So even within the Kalam tradition, there were these really interesting challenges to the mainstream view.
For sure. It just shows how intellectually dynamic this period was.
Okay, let's shift gears and talk about falsafa. You know, that other big intellectual current in the medieval Islamic world, the one that was heavily influenced by Aristotle.
Right, falsafa. They had a very different approach to natural philosophy than the Kalam.
Much more focused on Aristotle's ideas.
Yeah, they were all about citing Aristotle's physics and the tons of commentaries that had been written on them over the centuries. And their main goal was to understand the world in terms of change and motion.
Following Aristotle's idea that nature is an internal source of movement and rest.
Precisely. So for them, figuring out what motion is was a big deal.
And of course, Aristotle had his famous definition, entelechia of potential insofar as it is such. Which, let's be honest, is a bit of a mouthful.
It's notoriously dense.
Right.
And how they translated entelekia into Arabic had a big impact on how they interpreted it. They used the word kamal, which means perfection or actuality.
Okay, so instead of entelekia, they're talking about kamal.
Yeah, which kind of steered them away from seeing motion as just a process.
Because perfection doesn't really sound like a process.
Right, so they had to figure out how this idea of perfection could apply to something like motion, which seems incomplete until it reaches its goal.
Yeah, if something's still moving, it's not perfect yet.
Yeah, that's the problem. But Avicenna, the big name in falsafa, had a clever solution. He distinguished between traversal motion and intermedial motion.
Two kinds of motion.
In a way, traversal motion is basically our mental picture of an object moving from point A to point B. It's how we conceptualize motion.
Like tracing the path of a ball as it flies through the air.
Exactly. But intermedial motion, that's the actual reality of motion at any given instant. Avicenna defined it as the perfection of the moving object as it exists in an intermediate state.
So, at every point along its path, the object is perfecting its being in that moment.
Yeah, and the continuous succession of those instantaneous perfections is what makes up the process of motion. He figured that if something's perfecting itself at every point along the way.
It must be in motion over time.
Right. And the fact that it occupies each point for only an instant means it can't come to rest there.
Clever. So, for Avicenna, motion is this series of momentary actualizations along a path.
A very nuanced way of understanding Aristotle's definition, but not everyone agreed with him.
Of course not. What did the other folks say?
Well, you had guys like Abul Barakat al-Baghdadi and Fakhr al-Din al-Razi. They preferred to define motion as a gradual emergence from potentiality to actuality.
So, it's not about instantaneous perfections, but about a continuous process of becoming.
Right. Avicenna himself had considered this definition, but thought it was circular. He said, gradual implies the passage of time, but time itself is defined by motion.
So, you're defining motion with a concept that already depends on motion.
That's the problem. But Abul Barakat had a counter-argument. He appealed to this idea of better known to us versus better known by nature. It's a distinction that goes back to Aristotle.
Okay, break that down for me.
So Abul Barakat said that we first understand gradual through our senses. It's a basic pre-theoretical concept for us.
Like we see things changing gradually all the time.
Exactly. So we can use that understanding of gradual to define motion. And then, once we have a better grasp of motion, we can define time more precisely. Al-Razi really liked this view too. He emphasized how basic and sensory our concept of gradual is.
So, they're saying our intuitive understanding of change can be a starting point, even if we later develop more scientific definitions of motion and time.
That's the gist. But then along comes Mullah Sadra, this later philosopher, and he revisits the whole debate.
And who does he side with?
He ends up defending Avicenna. He argues that Abu Barakat and Al-Razi's attempt to break the circularity fails because they're using the word motion in two different ways.
Two different ways.
Yet when they say we understand gradual through our experience of motion, they're talking about traversal motion, like the observable movement from one point to another.
The kind of motion we see every day.
Right. But when they use gradual to define motion, they're implicitly talking about intermediate motion, those instantaneous perfections.
Ah, I see. So the meaning of motion shifts in their argument, which messes up their logic.
Exactly. So Mullah Sadra sticks with Avicenna's view of motion at an instant as the key to understanding Aristotle's definition.
It's amazing how much thought they put into these fundamental concepts. They really went deep.
They did. And this attention to detail shows up in their discussions of the infinite and the continuous too, which were often direct responses to the atomist views.
Right, because the atomists were all about discrete, indivisible parts.
Yeah, and the Falsafa folks had some major objections to that. The standard argument against an actual infinite goes back to Al-Kindi.
Okay, what's the argument?
Imagine two infinite lines, and you remove a finite segment from one. If they were truly actually infinite, removing a finite part shouldn't make one any less infinite than the other.
They should still both be infinite.
But if you try to match them up, you'll have a remainder, which creates a contradiction. Al-Kindi even used this logic to argue for a finite past, which most later Falsafa thinkers disagreed with.
Why did they disagree?
Because they said the argument only shows that you can't have a completed actual infinite, an infinity where all the parts exist at once and can be counted.
Okay, so a completed actual infinite is impossible.
But a potential infinite is okay, like the infinite divisibility of a line or the never-ending flow of time.
those infinities are fine because they're not all there at once.
Exactly. And they use this idea of the potential infinite to explain the continuous following Aristotle's definition.
Remind me of Aristotle's definition again.
He said a continuous magnitude is one where the touching limits become one. It's infinitely divisible, but it's still one unified thing.
So the atomists said continua are made of discrete parts, but the falsafa said no, it's fundamentally one thing.
Right. And they said that just because we can conceptually divide a line infinitely doesn't mean it's actually made of an infinite number of parts.
It's just a thought experiment.
Yeah. And that brings us to their criticisms of atomism and the idea of minima naturalia. These weren't just abstract objections. They had philosophical and even proto-scientific concerns.
Okay, what were they worried about?
Well, on a mathematical level, they pointed out that if space is made of discrete atoms, you run into problems with things like the Pythagorean theorem.
Like the diagonal of a square on a chessboard.
Exactly. If the chessboard is made of atoms, the diagonal wouldn't fit neatly into that grid. It would be a weird, irrational length.
That doesn't sound good for a system that's supposed to explain the world.
Right. And then there was the philosophical problem of aggregation.
How do you get from these simple, featureless atoms to the complex and unified objects we see around us?
Yeah, how do they combine? They considered all sorts of possibilities.
Yeah.
Simple succession, contiguity, true continuity, even interpenetration.
Yeah.
But they had found problems with all of them.
So no matter how you try to put atoms together, it doesn't quite work.
They thought so. One of their arguments was this thought experiment with 3 atoms touching each other.
Okay, 3 atoms. What happens?
Well, if they're truly indivisible, where does one atom end and the next one begin?
There has to be some kind of boundary, right?
But that boundary implies that even these supposedly indivisible atoms can be conceptually divided, which creates a contradiction.
That's a really clever argument.
It is. But even though they rejected conceptually minimal parts, they did believe in minima naturalia.
Minima naturalia, what are those?
It's like the smallest possible piece of a specific substance that can still retain the properties of that substance. If you divide it further, it basically stops being that substance and might turn into something else.
Okay, so it's not about absolute indivisibility, but about the limits of how much you can divide something before it fundamentally changes.
Right. And their arguments for minima naturalia often relied on their understanding of elements in substantial forms. They said that as you divide a substance, it becomes more and more vulnerable to external influences.
Like a tiny drop of water is more likely to evaporate than a big puddle.
Exactly. So below a certain size, the minimum naturalia for that substance, those external influences overwhelm the substance's inherent qualities, and it loses its form.
It's like it loses its identity.
Yeah, and potentially transforms into something else.
Makes sense. All right, let's move on to place and void. We talked about Aristotle's definition of place as the inner boundary of the containing body, but Philoponus had some serious issues with that. How did the falsafa thinkers respond to his criticisms?
They tried to find ways to reconcile Aristotle's definition with Philoponus's objections. Remember, Philoponus argued that if place is the boundary of a container, then what contains the outermost celestial sphere as it rotates?
Right, what's outside the universe?
Exactly. He thought place was more like a self-subsistent three-dimensional extension. Now, most falsafa thinkers still liked Aristotle's definition, but they tried to address Philoponus's problem. Avicenna, for instance, said that the universe as a whole doesn't have a place.
The universe doesn't have a place.
Not in the Aristotelian sense. To explain the movement of the heavens, he added motion with respect to position to Aristotle's categories of motion.
Which is basically rotation.
Right. He said that kind of motion doesn't need a containing body in the same way that linear motion does.
So the universe can rotate without being inside something else.
Yeah. Now, Ibn Bajjah and Averroes took a slightly different approach. They actually modified Aristotle's definition of place.
How do they modify it?
They said place is the proximate surrounding surface, and they distinguished between concave surfaces for linear motion and convex surfaces for circular motion.
Okay, so different kinds of surfaces for different kinds of motion.
They then argued that the Earth's convex surface could be considered the place of the universe, although Averroes thought this was just an accidental feature of the universe.
So they found ways to tweak Aristotle's definition to make it work.
They did. And their commitment to Aristotle's view of place was tied to their rejection of the void, which was a big deal for Philoponus.
Right, Philoponus saw place as this independent extension, which kind of implied the existence of a void.
Exactly. But most falsafa thinkers thought the void was both physically impossible and conceptually incoherent.
Like, it just doesn't make sense for there to be truly empty space.
Al-Kindi argued that the very idea of place depends on something being placed. You can't have one without the other. So a place where nothing is placed is a contradiction.
It's like trying to imagine a container with nothing inside it.
Al-Farabi also chimed in. He looked at arguments for the void, like the supposed emptiness in a sealed vial, and said that what we think is empty is actually just very thin air.
Like a subtle form of matter that we can't easily perceive.
Yeah, he also said it doesn't make sense for nothingness to have dimensions.
So for them, the void was either a subtle form of matter or just an expansion of existing matter.
Right.
Okay, let's talk about time and eternity. We mentioned that the falsafa generally accepted Aristotle's definition of time as the measure of motion.
The measure of change with respect to before and after.
But Averroes pointed out some pretty big problems with that.
He did. He basically asked, if time is the measure of motion, which motion are we talking about?
Is there one universal motion that time is based on, or does every motion have its own time?
That's the dilemma. If every motion has its own time, you end up with multiple, maybe incompatible time frames, which seems weird.
Yeah, that doesn't sound right.
But if time is only linked to the motion of the celestial spheres, as Aristotle suggested,
Then people who don't know about the movements of the heavens wouldn't be able to experience time.
which doesn't match up with our everyday experience. So Averroes had to find a way out of this mess.
What was his solution?
He said that our primary awareness of time comes from our internal experience of change.
So our own personal sense of time passing.
Right. But he also said that this internal experience is ultimately grounded in and measured by the steady motion of the heavens.
So our subjective experience of time is tied to an objective cosmic clock.
That's how he reconciled things.
Clever. And then there's the question of whether time is finite or infinite, linear or cyclical.
The big questions. So you had different views within falsafa. Al-Kindi, consistent with his arguments against the actual infinite, believed in a finite past.
A beginning of time.
But most other falsafa thinkers, like Avicenna, argued for an infinite time, although they didn't all agree on its structure.
Different kinds of infinity.
Avicenna liked the idea of a linear, infinite timeline. He said that for any proposed first moment, there would always have been the potential for change before it, pushing the beginning back forever.
So no first moment.
But Averroes, remember his emphasis on the cyclical nature of celestial motion. He thought time was cyclical too. Every point in time is both a beginning and an end, constantly repeating.
A never-ending loop.
That-
Two very different ways of thinking about time.
For sure. Now, we should also mention Al-Razi, who was a bit of an independent thinker within falsafa.
Razi, he was the one with the 5 internal principles.
Yeah, he had this doctrine of 5 eternals. The creator, the universal soul, prime matter, absolute time, and absolute space.
Absolute time and absolute space.
He called absolute time duration and absolute space void. And these were pretty unique ideas in this context.
Yeah.
He distinguished between relative time and place, which depend on motion and objects,
Like the time it takes for a ball to roll across a table.
and absolute duration and void, which he said exist independently of all that.
So even if there were no objects or motion, there would still be time and space.
That was his view. He had a really interesting argument for the eternity of duration. He said our experience of time is always about things coming into being and passing away.
The present moment is always fleeting.
And he said that kind of time requires an underlying, unchanging duration to make sense. Otherwise, you'd have this infinite regress of moments depending on other moments.
So there has to be a fundamental internal time that all these relative times are grounded in.
Exactly. And he had a compelling argument for the void, too. He asked us to imagine the entire universe being destroyed.
Nothing left but empty space.
He said that even then, the concept of empty space, of void, would still be there, unlike the concept of place, which depends on